Welcome to HoloSAR, the SAR simulation educational tool for the Microsoft HoloLens. This tool is intended to provide students and educators with a more hands-on approach towards synthetic aperture radar simulation. As you can already see, you get to be there with the radar and see really how the acquisition works. So the main environment of the educational tool consists of three main parts. One is the actual scene, in which you have a digital terrain model which you can manipulate and move around, and also you have the flying satellite, which also can be moved and its parameters can be changed, as well as the start and end point of the trajectory. And in this case you are completely free to move all of the elements into any geometric configuration that you would prefer. You are also allowed to change different parameters of the acquisition, which is provided by this configuration pane. So for example, you can change the view angle of the beam. So right now the beam is pointing approximately horizontally, but I can change it to point more downwards. So you can see, as I'm adjusting the slider, the incidence angle of the acquisition is changing. The same thing you can do with the near and far range of the acquisition. So I can change to move the near range, the starting near range point of the acquisition further away. And so now I am covering approximately the scene that I want to cover. You can also adjust the beam height. So you can see the beam height is changing, and also the beam width. And then the third part of the user interface is, of course, the display of the acquired data. So let's now acquire some data to see how it looks like when it is finished. So after we are happy with the settings of our acquisition, so we have defined our trajectory by the starting and ending position of the satellite. We have defined our acquisition parameters. We just click Start Acquisition. And now the satellite has started acquiring, and all the data is being simulated in real time according to the parameters of the acquisition. And we can see already some data starting to come in and getting displayed in almost real time as the satellite has acquired it. But we do not see much in this data. It really just seems like random noise, and this is because this is the raw data of the acquisition, and we need to perform range and azimuth compression. So the first thing we do is we click the compress button to perform range compression, and now we can see that okay, something has happened at the edges, and we can see that yes, the data now is a little bit less random. However, it still doesn't have a very high resolution, and that's because it's still defocused in azimuth. And so now we can do the same thing and focus it in azimuth. And now we have the final data. So this is the range compressed and azimuth compressed data. The color represents the phase of the signal incoming from different parts of the scene, and the intensity represents the scattering intensity. So here we have an acquisition of two targets. So we can see that we have a terrain in the background, and in the front we have placed a small object which we can manipulate, and it's a sphere, in order to show what the shadowing effects in synthetic aperture radar look like. So again, we have adjusted our start and end position, and now we can launch the acquisition. And we see the radar is now acquiring data, and you can observe that now the sphere has entered the field of view, and now it has again left from the field of view. And now, observing the acquired data, we can see the image of the sphere very nicely here in the front. in the near range because it's closer than the terrain, and also as the sphere is going we can see small amounts of shadowing or obstructed terrain that has been caused by the casting of the shadow of this sphere inside of this region. So this is also something that happens, is that while you have your multiple targets are within your beam, then this kind of obstruction, where you can see that from the view of here we cannot see the valley that is behind the sphere, and this is also an effect that is present within real synthetic aperture radar acquisitions. So here you can very clearly see the profile, and you can see the valley in the data because the incidence angle is so shallow, but you have a lot of shadow, so you cannot cover all areas. But now if we move the radar up like this and we turn the beam angle down, and so now if we look from here, then now the shadows will be gone. But on the other hand, it's like the whole thing will be a little bit squished in the range, so it will have a narrower range from the top. You can see that it's only like in a smaller span of the available ranges, and if we go all the way to basically where the radar is just looking completely downwards, so completely vertically, so it's gonna take it a while to update. Yes, so now it's looking completely down, and now it's gonna be a very narrow strip, and you are gonna lose the resolution of what is near and what is far. Yes, so now you can see that you have really a tiny narrow strip. And actually this thing here, I believe that was my cursor that was flying around there, because it actually also images the cursor. So yeah, I guess that's how it works like a radar.